Hi everyone. In today's video, I want to talk about a really important contract within Java, and that is the equals hashCode contract. In this video, I want to do more of a deep dive into this contract, and I want to talk about some of the things that you should consider when you're implementing equals or hashCode. Oftentimes, the main thing you hear is that when you override hashCode, you should always override equals or vice versa. That's good advice, but it only really scratches the surface. There are a lot of other things you should think about when you are overriding these methods, and I hope to cover those today. Let's get into IntelliJ, and I'll start with talking about the equals method. All right, so for today's project, we'll call it equals hashCode. All right, so I'm gonna go ahead and pull up the main class that was generated. And just to keep things simple, I'm gonna go ahead and do everything in this one file here. I'm gonna go ahead and make a static class called parent. And then I'm going to make a static class called child, which is going to extend parent, because some of the things I need to demonstrate involve inheritance patterns with equals and hashCode. And then what I'll do is I will create an instance of parent, and I'm going to actually create 3 of them to demonstrate all the things you should consider when you're looking at equals. So I'll go ahead and do that now. So the first thing when you're writing an equals method is you need to make sure that your equals method is reflexive. What that means is that x.equals x always has to equal true for any non-null reference x. The second thing you want to do is when you're writing an equals method, you need to make sure that it is symmetric. So what that means is x.equals y needs to exactly equal y.equals x for x, y doesn't equal null. And the third thing is you want to make sure that the relationship is transitive. What that means is that x equals y equals z. And I am doing a little bit of shorthand here. In this case, I am not talking about exact reference equality. I'm talking about an equals relationship. And the writing code to do that's not quite as straightforward as these first two, so that's why I'm writing it like this. The fourth consideration is that it needs to be consistent. So if you do x.equals y, if you don't change anything about x and y, you should be able to call x.equals y and it should return the same value again later. Then for number 5, you want to say that a non-null reference is never null. So what that means is x.equals null has to equal false. All right, so that's for a number of rules. So let's go ahead and start implementing the rules and seeing where we can make equals methods that satisfy these rules and those that don't. So let's go ahead and start with just the default implementation of equals, which is inherited by object. And what we can do to verify number 1 is we can say var1 dot equals var1. Then what we can do for 2 is we can say var1 dot equals var2 equals var2 dot equals var1. And then what we can do for transitive, it's a little bit harder to show. What I'll go ahead and do here is I'll just print out the values. So I'm going to use Boolean conversion specifiers. And I actually don't need to format it because I'm already formatting it with printf. var2 equals var3, and then var1 dot equals var3. All right. So this one's a little bit harder to do. In this case, I'm going to iterate over calling equals over and over again, and I'm going to show that it doesn't change after the initial value. All right, so to go over what this code is doing, we have a label here, and then we have a break with a label, which is actually a Java feature not too many people know about. What it's doing here is if we exit the case that we're talking about, we break out of this labeled scope right here, and then we exit down here. Otherwise, if we complete the loop and we never hit the case mentioned here, then we go ahead and print true, and that means that we had consistency. All right, now for the last one, which is a good bit easier, we can say var1 dot equals null should always be false. Let's go ahead and run this code with the default implementation of object and make sure that everything looks good. All right, so looking at the results, the first one is true, which looks good. That means that it's reflexive. The second one is symmetric. These are equal. The third one is transitive, meaning that all three of these relationships are the same. And that looks good. They're all false. This middle one here is true, and I should be consistent. And I'll make these lowercase. And the bottom one is true. So this looks good. So the default implementation of object for equals passes the tests. Now let's go ahead and play around with some different implementations of equals and see where we can break this. First, I'll start with one that is really straightforward. And what this is saying is no object that is a parent class is ever equal to any other parent class object. Let's see if this passes. All right, so we will note that this does not pass the test because the first property, the reflexive, is false because when we check against ourselves, it doesn't work. So let's change these all to true, and then we'll run this test. All right, and that one doesn't work either because the first four work, but the last one doesn't. In the case of the last one, we should be validating that we have null, and when null is the value that gets passed in, we should always return false. So this equals method is also not fitting the contract. So let's make a few little tweaks to this. Let's go ahead and say if object equals this. All right, so this looks more like the default implementation from the object class, where this passes all the tests, but really all we're doing here is just reference verification. What happens if I want to have some equality when my fields are the same? So I'm gonna call this field 1, and I'll go ahead and give it a value of 6. If I run this code, we can see that we pass all of the tests within the contract, but when we look at the transitive property here, everything is false, even though it does pass and it is transitive. All of these, which are constructed the same way, none of them are actually equal, but I wanna change that. So let's go ahead and update the code a little bit. In this case, we start with an object, and now we need to compare field 1. So to do that, you need a downcast. So let's go ahead and make a parent other, which equals parent of object. And then now we can do return other.field1 equals this dot field 1, and I need a double equals. All right. Do we think this is going to work? Okay. So when I look at the first 4 tests, everything looks good, but then on the 5th test, I have a null check here that failed. So I need to do some protections around null. So really what I should do is I should say if object equals null, then I want to return false. Otherwise, I can continue on with the processing as I am. All right, cool. So now this looks better, but there's still problems. So now I'm going to go ahead and change this to object. And I'm going to comment out var3, and I'm going to comment out the transitive line because not everything's actually going to be equal in this case. And we'll set this equal to an object as well. All right, now we have an issue called a class cast exception. And the reason we have this is because we are trying to do a downcast, and we haven't verified whether this is actually an instance. So to do that, you can actually combine the null and the instance of checks in one, because instance of also verifies if a reference is null. If object instance of parent. So when we enter this if, we know that we are dealing with a parent. So this is where I could do a comparison like this. And in this case, I'm going to return false. And we're back to this looking good again. Cool. Next, I want to add another little gotcha, and that is we're going to go ahead, instead of saying object, we're going to say child here. When I run that code, we still get all trues here. And that's because my child isn't overriding my equals comparison here. So I'm gonna go ahead and override equals. In this case, let's say something pretty similar. Except we want to be instance of child. And we're going to go ahead and add another field here. And we want to compare field 2. Let's go ahead and try this and see what it does. All right, so we've got an issue. Item number 2, symmetric. This is the one that bites a lot of programmers whenever they're using equals and they don't think about inheritance relationships. You got to be really careful here because this is one where if you are implementing inheritance and you weren't envisioning that inheritance would be in your code and now it is, this can lead to strange bugs. And I want to highlight this one as one that people often mess up. So what can we do to fix this? Well, one thing is that the instance of, even though it's quite nice where it does the null check and the instance check so you can do the downcast, it's not restrictive enough for subclasses because a parent is an instance of a parent, but a child is also an instance of a parent. So really what you want to do, if you want to verify that you are dealing with a parent and only a parent, you'll want to do if object equals null, like before. And then next you would want to do, what you'd want to do is you would say object.getClass doesn't equal this.getClass. And this is also another case to return false. And then after that, now you know you're dealing with a parent. And you can say this like so. And if we condense this down a little bit, we can actually do this all in one line if we really wanted to. There we go. All right, let's go ahead and do the same thing in child and see how this looks. All right, good. So now I think our equals methods are looking a good bit better. Some people may choose within the subclass equals method to include some data members within the parent class to verify that those are the same as well. You can do that. Just the thing you got to be careful about is if you call super.equals, you can't verify that the super implementation of equals is always true because it won't be after you add in a class check like this. But at the same time, if you take it out and you use instance of, then there's no easy way to guarantee that subclasses don't add additional functionality on that your base class can't already verify. So then you potentially miss the case that we were looking at here where you get asymmetric relationships among equals. Okay, so now that we've implemented equals, I'm gonna go ahead and change this back to a parent. And what I want to do next is I want to demonstrate why after you implement equals, you have to implement hashCode. What we're going to do here is we're going to create a map, a parent to string. And we're going to have a hash map. And what needs to happen is I want to add in var1 with a value of var1. Now I want to do this 2 more times. All right, so an important thing to know about hashmap is that it doesn't allow duplicate keys. So what it does is it replaces a current key if there's a duplicate in the map with the key that was just inserted and then the value associated with that. So for instance, if I put all 3 of these in here and I ask for key var1, I should expect to get var3. And if I put in var3, I should expect to get var3. var2 should also get var3. And also I would expect this map to have a size of 1. So I'm gonna go ahead and try those out. Let's look at the map size. And then let's go ahead and look at map.get var1 and see what these print out. Interesting. So this is a consequence of having equals and hashcode different. While we would expect the map to condense down into a single entry and only have var3 in it, what we actually have is a map that is size 3 and var1 is still mapped to var1. Because really what's happening here is the key within a hash map is based off of the hash code, not the equals method. So what we need to do here is we need to override hash code and have it match equals. So I'll go ahead and do that here to start. Let's override hash code. And let's go ahead and make it simple and just do objects.hash field1. Some people will do super.hashcode times the fields, especially because we're talking about an integer here. It will just overflow if it goes above a certain value, which is totally fine in this case. So let's go ahead and do the same for child just for completeness. And we'll run this code and see if it results in different behavior. This is a bit of a head scratcher. What's going on here? Well, the super.hashcode has a unique hash code for each new object reference. So you might be thinking, oh, I'm adding a little bit of extra randomness in here to get the hash code to be what I want it to be, but I actually don't want to do that in this case. Instead, if you just use the current field's data, what will happen is you're not going to get muddied by the default implementation of object hash code, which is unique per reference when you want a data member to have some sort of equality of the hash code. So instead, let's go run this and see if this looks better. All right, much better. So now we have a map size of 1, and we have var1, which originally had the value var1 in the map, and now it got replaced with var3 because it got overwritten. So now this looks like how we would expect it to look. Excellent. Now I'm going to go ahead and mess with this a little bit, and I'm going to go ahead and add randomness to demonstrate that that leads to very strange behavior. Now instead, I want to do random.nextInt. Now, what do you think is going to happen this time? Interesting. So we're back to a map size of 3. But now this time we tried to get the value out with the key that we set and we got null. So this is another very important thing about hash code. Hash code should always, like equals, it should be consistent. Because what'll happen is when you do a get call like this, it's calling var1.hashcode and it's looking through its internal entries to see if it has that same hash code. And since the hash code that we had here was randomized, it's not going to find anything, so it's going to return null. Isn't that confusing? So if you want to have a little fun with a classmate, a coworker, or with yourself, change the default implementation of hash code and see what kind of weird behavior you get. Now, one other really quick thing I want to mention here is that most good IDEs offer default implementations for equals and hash code. So if you look here, it says generate via wizard. And it's asking me which fields I want to be included in hash code. So I'm going to go ahead and create. And would you look at that? It generated the same method that otherwise I would have generated. Let's go ahead and do the same thing for equals and see how that looks. It's asking if I want to use a particular template. Yeah, that looks good. Accept subclasses as parametered equals method. Sure. Maybe necessary. So you can see right here that it warns you about the sub and superclass implementation details. So let's think critically about this IDE generated equals method and think about whether it meets the contract. If the references are exactly equal, it returns true. If we're an instance of parent, we continue down here and we compare equality of the fields. Otherwise, we return false. I don't know if this is going to do what we want. Let's go ahead and run it to test. So this actually looks okay now, and the reason is because I forgot to change this code up here. So I'm going to do that quick. And I'm going to get rid of the transitive check. All right, so now we're back to where we started. Unfortunately, the IDE's equals method didn't account for the symmetric property that we're looking for with equals. So that's a little unfortunate. So this is why I say that IDEs are good tools, but you as a programmer still have the responsibility to verify what it's generating, and you should write good test code to verify if the behavior is what you expect it to be. So one more thing about hashCode that's a little interesting is when equals is true, hashCode has to be the same across two object references. When equals is false, the hashCode across two object references should be different, but it doesn't have to be. If the references have different hashcodes, that can help optimize implementations that use hashcodes, but they don't strictly have to be different. So for instance, what I could do is I could just return a hashcode of 8 every single time here, and this code would still work, but it wouldn't be as well optimized versus if I had unique hashcodes for everything. Now, the main reason they do that, one of the reasons that they do this is because even though the likelihood of collision is low, if you have some sort of randomness or otherwise calculated differences with your hash codes, there's still a, albeit minuscule, chance that you can have a collision. If you're talking about 4 bytes in your integers, if you recall, that leads to a total of about 4 billion values. If you assume a random distribution of the values, if you're talking 1/4 billion chance, that's not very high. But if you think about the fact that you're having code running constantly, and let's say you could do 100,000 or 1 million hash code comparisons in a second, depending on how good of a computer you have, it doesn't take all that long to hit 4 billion. That's why the language designers didn't make it a strict requirement that hash code had to not be equal when equals was not equal, but it certainly does help implementations. And that's the gist of the equals hashcode contract. I hope you found that useful. I know that for me, when I really started to take more of a deep dive into the requirements of equals in hashcode, I was kind of like, oh, there's a lot more to this than I realized. So if you had any epiphanies, I hope that this video was helpful. And if you didn't have any epiphanies, I hope that this video was a good review for you. Thank you for watching this video. I hope you have a good rest of your day, and I hope to see you next time. Take care.